Hello. Welcome to the QO TDCC8 user guide video. In this tutorial, you will learn how to set up, configure, and operate the time digital converter and correlation device step by step. First, let us start with an introduction to the device. The time digital converter device is presented here as shown. As can be seen, the device features an output channel, a start channel, and 8 separate input channels. At the rear panel of the device, you will find the reference clock output, a secondary output channel, the power connector, a micro USB interface, an Ethernet port, and an SD card slot. For proper operation, the device requires a 5-volt power supply connection and an active Ethernet link. Once all connections are in place, press the power button to switch on the device, and then proceed with the IP configuration required to access its interface. There are 2 different methods to configure the Ethernet settings. From the desktop, type Ethernet settings into the search bar and click on the first result. On the screen that appears, click the Edit button next to the IP assignment setting and choose Manual. After that, enable IPv4. IP address is 192.168.111. Subnet mask is 255.255.255.0. And then click Save to confirm the changes. For the second method, type Control Panel to search bar and open the first option that appears. In the Control Panel window, click on View Network Status and Tasks under the Network and Internet section. On the left side of the window, click on Change the Adapter Settings. Select the Ethernet connection that is linked to the time digital converter device. Click Properties. On Open Page, double-click on Internet Protocol version 4. After selecting, use the following IP address. IP address is 192.168.111. And subnet mask is 255.255.255.0. Make sure you checked Validate Settings upon exit at the bottom left, and then click OK. Make sure there is no error. After completing the settings, it's recommended to reopen and verify the configurations. To access the interface, user needs to enter the device's IP address, 192.168.110, into any web browser. If everything was set up correctly, user will be able to access the interface without any issues. If the interface does not open, check the Ethernet connection or restart the device and try accessing the interface again. Upon launching the interface, the Home tab appears first. On the left, a diagram of the device is displayed, illustrating the front and top views along with the input and output channels. In the center, a detailed description highlights the purpose and key features of the device. On the right, the Home tab also includes a temperature gauge and a control button to start temperature monitoring. The latest features and documentations can also be accessed from the Home tab. By clicking the moon and sun icons located at the top right of the interface, the user can switch between dark and light themes. The interface user manual can be accessed by clicking the book icon in the upper right corner of the screen. The Count Rates tab displays the real-time count rate measurements for each channel. On the right panel, control options are available to start and stop measurements, reset the graph size or zoom, and export data. On the left side, the graphs plot the counts per second, allowing the user to monitor individual channels or multiple channels simultaneously. Users can also switch between displaying multiple graphs or a single combined graph. Below, the count rates for all 8 channels are listed, each represented with a distinct color for easy identification. The count rate graphs include features such as zooming in and out, panning, and the zoom to rectangle function. The user can reset the zoom by pressing Shift+R or using the button in the interface, maximize any desired graph to full screen, or adjust the layout by resizing the graphs from the bottom left corner to create the most convenient view. The Configurations button, visible only when the Count Rates tab is open, allows users to fully customize all count rate graphs as desired. To better demonstrate the use of the interface, we will display the live data being transmitted to the device. As you can see, the count rate values for Channel 1 and Channel 2 are currently showing 0. For this demonstration, we will use a signal generator. As shown on the signal generator's display, the frequency of Channel 1 is set to 1 MHz. Similarly, Channel 2 of the signal generator is also set to 1 MHz, but this time we add a 10 nanosecond delay to Channel 2, which will be useful for our upcoming steps. Now I am connecting first output of the signal generator to Channel 1 of the R device and second output of the signal generator to Channel 2 of the R device. When the outputs of the signal generator are activated, you will see that the count rate values in the interface match those of the signal generator. Let's switch back to interface again. The histogram tab allows users to perform correlation and time difference measurements between selected channels. On the right panel, there are 4 tabs. The Acquisition tab allows the user to select the active channels for data collection and configure acquisition parameters. The acquisition time can be set manually, and the progress bar shows the status of data capture. Control buttons are provided to run, stop, or clear the histogram. The Histogram tab provides settings for correlation measurements. Users can define the start and stop channels, as well as configure parameters such as minimum and maximum range, bin count, and bin width in picoseconds. These settings determine the resolution and scale of the histogram. The Save tab manages download settings. Users can enable saving and specify the maximum chunk size for exported data files, ensuring efficient handling of large datasets. The Import tab allows users to import external data or run demonstration data. Controls are available to import files, start a demo, or stop a demo, with the import status displayed below. Now, let's examine the histogram features in practice. I select the acquisition time checkbox and set its value to 5. Next, under the connection section, I start the WebSocket connection using the Open Socket button. Press the Run button to start data acquisition and the correlation calculation. As you can see, the data transmitted from the signal generator was collected over 5 seconds and the correlation result was displayed on the graph in real time. Now let's run it again with 10 seconds of acquisition time. With the acquisition time checkbox disabled, acquisition and correlation will run continuously until stopped. While data acquisition is in progress, users can reset the histogram table using the Clear Histogram button. Let's go back to the device and proceed with the histogram tab using the signal generator. I selected my channels and pressed the Run button. Earlier, we set both outputs of the signal generator to 1 MHz and applied a 10 nanosecond delay to the second output. Now, by adjusting this delay value, we will observe the corresponding changes in the histogram graph in real time. As shown, real-time changes on the signal generator are directly reflected in the correlation graph. The histogram graph can be zoomed in for a more detailed examination. For better visibility, we return to the interface screen. Similarly, the delay value of the signal from the second output of the signal generator is continuously increased and decreased. Through the Configuration section, which is available only within the Histogram tab, users can adjust the text size and line thickness of the histogram graph according to their preference. Like the rest of the interface, this entire tab is also compatible with the dark theme. The Delay/Pattern Generator tab provides control of 2 independent generators. To demonstrate the features of this tab, I connect the device's output to channel 3. Similarly, I connect the out2 output at the back of the device to channel 4. Currently, out is connected to channel 3 and out2 to channel 4. After completing the connections, we return to the interface. The generator type can be selected from 3 modes: clock, single pulse, multiple pulse. In this demonstration, both are set to output clock signals, defined by adjustable parameters such as pulse width, pulse period, and delay. Following the previous connections, Generator 1 delivers its signal through the out1 channel to CH3, while Generator 2 delivers its signal through the out2 channel to CH4. These outputs can be monitored in the Count Rates tab. The correlation calculations of the signals from these output channels can also be analyzed in the histogram tab. The final section is the Update tab. Here, the firmware of the device can be updated with just 2 clicks. The interface displays the currently installed version and notifies the user when a newer version is available. Just click Update Firmware button and OK to start the update. Once the update is initiated, the new firmware will be installed within a maximum of 3 to 4 minutes. During the update, ensure that the Ethernet connection remains stable and that the device stays powered on. After the update is completed, the only step required is to restart both the interface and the device. In this video, we introduced the hardware, explored the interface, and demonstrated key features such as count rates, histogram analysis, and the delay/pattern generator. We also covered how to perform firmware updates to ensure your device remains up to date and reliable. With its high-speed FPGA architecture, flexible configuration options, and user-friendly interface, the QO TDCC8 is designed to deliver precision, efficiency, and full control for your experiments. Thank you for watching, and we wish you success in your research and applications.